Hi guys, we will be solving an O-level past paper question from the year 2021. The session is July-August. This is question number 8. We'll find the length, coordinates, midpoint and the equation of a perpendicular line in this question. So let's start. The question says A is the point -2 and 1 and B is the point 3 and 3. Part 1 says find the length of line AB. So in order to find the length of AB, you need to use the formula where it says x2 minus x1 plus y2 minus y1 and the whole thing is squared inside and then you find the square root of it. So you do 3 minus -2 whole squared plus 3 minus 1 whole squared. Let's see what we get. So AB is equal to the under root of 3 plus 2 is 5, 5 squared is 25, 25 plus 3 minus 1 is 2, 2 squared is 4, so you get 29. Let's see what the square root of 29 is. 29 square rooted, we get 5.39 units, and that's our answer to part 1, 5.39. Okay, the next part says ABCD is a square with sides AB, BC, CD and DA. So it's a square and point C is below the x-axis. Find the coordinates of point C. Okay, let's draw the square first. It's a rough drawing, but it'll give us an estimate. Hold on 1 second. So I hope this looks like a square in the end. Okay, more or less. Okay, so A is over here, B is over here, C is over here, D is over here. This is a rough idea of what it looks like. The coordinates of A were in part 1, -2 and 1. The coordinates of B in part 1 were 3 and 3. We had to find the coordinates of C over here. Okay, in order to move from A to B, you had to move 1, 2, 3, 4, 5 places to the right and how many places? 2 places up. That means you move 5 places to the right and 2 places up. If this is a square and if this is the amount of movement that you have to do from going from one point to the other, so therefore when you go from B to C, you would need to move 5 places down, that's -5, and 2 places to the right. So you have -5 and +2. Okay, but what do we do with this? So let's find the vector. So we're trying to find the vector OC. Okay, and OC is equal to the vector OB plus the vector BC. So the vector OC over here is equal to the vector OB, which is 3 and 3, plus the vector BC. BC is the vector, the movement that you're doing from B to C is you're going -5 places down. That means, X comes first, my bad. You're going 5 places down and 2 places to the right. So in other words, you're going 2 places to the right and 5 places down. So when you subtract or add both of them, you get 3 plus 2, which gives us 5, and 3 minus 5, which gives us -2. So the coordinates of C are 5 and -2. We write our values over here, 5, -2. Let's move on to the next part. The next part says P is the point -7 and 8 and Q is the point 9 and 4. Part 1 says find the coordinates of the midpoint of line PQ. Okay, so the midpoint, let's call this mid. We would need to do x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So we have -7 plus 9 divided by 2, that's for x, and we have 8 plus 4 divided by 2, that's for y. So let's find out what we get. -7 plus 9, this gives us 2, 2 divided by 2 gives us 1, and then for y it's 8 plus 4, which is 12, 12 divided by 2, it gives us 6. So the coordinates of the midpoint are 1 and 6. The next part says find the equation of the perpendicular bisector of PQ. Okay, first of all, if we find the gradient of PQ, since we're trying to find the perpendicular bisector's equation, if you find the gradient of PQ, let's call it M1. Okay, M1 is supposed to be y2 minus y1 over x2 minus x1. If you find the gradient, since Q is the point on the right and P is the point on the left, we do 4 minus 8 divided by 9 minus -7. Okay, when we do this, we get -4 over 16. When we simplify this, we get -1 over 4. This is the gradient M1 for PQ. If you have to find the gradient of the perpendicular bisector, which we call M2, let's see what M2 is. If we multiply the gradient of one line and the other line, and if they are perpendicular bisectors of each other, they should always get a product of -1. So basically we're trying to look for M2. So M2 is supposed to be 1, -1 divided by M1, or in other words, it is going to be negative 1 divided by 1 over 4, negative 1 over 4. So if you solve this further, this becomes negative 1 times negative 4 over 1. If you multiply this, we get 4. So the gradient m2 of the perpendicular bisector is going to be 4. Okay, let's find the equation of the line perpendicular to PQ. Okay, we have the coordinates of the middle point of PQ, and since perpendicular bisector goes through the middle of PQ, so the coordinates that we are going to use are 1 and 6, and the gradient that we are going to use is m2, which is 4. And the equation that we are going to use is y minus y1 equals m times x minus, sorry, one second. We are going to use x minus x1. Okay, let's plug these values. Y minus 6 equals 4 times x minus 1. Let's open this up. We get y minus 6 equal to 4x minus 4. Then we get y equal to 4x minus 4 plus 2. This gives us y equal to 4x minus 2. This is our final equation of the perpendicular bisector. We write it over here, y equal to 4x plus 2. Sorry, not plus 2. It is going to be minus 2 over here, and we're done with the question. Sorry, my bad. It is not going to be negative 2. My bad. It is going to be positive 2. I made a mistake over here. It is negative 4 plus 6. So this is going to be plus 6. So I write positive 2 over here, and this is also going to be positive 2. Now we are done. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.